In our last video, we got started with coding a CPX or Circuit Playground Express using CircuitPython and an awesome IDE called Mu. Today, we're going to expand on that and we're going to start programming these 10 RGB LEDs called NeoPixels that are built onto the board. Like I said earlier in another video, the CPX is loaded with tons of great sensors, and it's also got these RGB NeoPixels around the perimeter, and they're really easy to program using the CPX module. Let's get started right away. So I'm going to open up Mu, just like last time. I'm going to make a new program. And just like last time, the first thing I'm going to do is from the Adafruit library, it's the Adafruit Circuit Playground Express library. I'm going to import CPX. That's going to come with a whole bunch of cool things that I can do. Then the next thing I'm going to do is I'm going to enter into a while loop. So I'm going to import the modules I need as CPX, and then I'm going to cause my program just to enter into an infinite loop, so it'll do everything I ask it to do under the while loop over and over and over forever. So let's get started. Just turn some of those pixels on. Here's a simple way to do that. CPX. I can say CPX because I just imported it. Otherwise, that wouldn't make a lot of sense. And I can say CPX dot pixels. That is something that's built in, and that built-in object that comes with the CPX module, that object has a function built in called fill. And the way I'm going to fill is I have to give the fill function a grouping of 3 numbers. Let's try 100, 0, 0. So this grouping, notice I've grouped all 3 numbers in parentheses, and those 3 numbers stand for RGB, red, green, blue. If you know anything about computers run on RGB. Your monitor, your watch, your phone, everything, well, not my watch, but fancy watches, have display colors using RGB because, not to get too into it, we humans are trichromats. We've got RGB sensors in our eyes. But so these pixels on these 10 LEDs around the perimeter of my CPX accept an RGB number, and it's an 8-bit number, which means it goes from 0 to 2 to the 8th, which is 256, or actually 1 to 256, or 0 to 255. Not to get too into it, but 0 to 255 is the acceptable ranges. So 0 would mean completely off, 255 would mean completely on, 100 is a little bit there in the middle. So let's just try that, see what happens. So I have to name it code.py. If I name it code.py, it should turn on. There we go. I've got a bunch of red LEDs because I've used R. Red is the first of the 3. Now if I change that to 0, then 100, that would be green. If I just hit save. And by the way, I mentioned this in the last video, it's so fun to develop in CircuitPython because you literally hit Control S and you're running your code. No compiling necessary. It's pretty fun. And then if I change that to 100 for the last number, that's the blue, red, green, blue. Now, if I want to do combinations, I can do that. Of course, if I do 100 for both the green and the blue, there's sort of a greenish blue, et cetera, et cetera. And I think if I were to do 100 for all of them, that would be white. There's no such thing as white, but you might remember from school, if you put all the colors together, or at least the ones that a human sees, a human's going to perceive that as white. Okay. You might want to go, let's see, if I went to if I Googled, whoa, what just happened? Oh my gosh. That was crazy. Okay, if I Googled RGB color picker or something like that, I could find, I think Google even has one for me. Yeah, there's one. So I can actually just pick a color. So I like this pinkish color over here, and that's 235, 52, 204. Whoops. Yeah. All right. So I'm going to paste that in here. Hit save. And that's a nice pink color. I like that. Okay. So that's basically that's a really quick way to make all the pixels the same color by using the .fill function. I can address these guys individually by giving them a number between 0 and 9. There's 10 of them. The first one is 0, the last one is 9. So if I say I just want NeoPixel 6, if I want the 6th one, that'll be the 7th one, equals, and I can give it that same, maybe I'll just give it that same pink number. And now one of them is that pink number. So you could imagine I can address 2 of them. So let's make this guy, I don't know, let's make him just red. And so if I do red with no green or blue, hit Control S, I've now addressed 2 of them. I've got a pink one and a red one. So you can imagine all the fun possibilities there. I'm going to give us one more quick lesson before we wrap this video up, and that's how to use another loop called a for loop. So in programming, it's often important and helpful to be able to do something a lot of different times over and over. While loop is super helpful. So is a for loop. Let's do a for loop. I could say, in order to write a for loop, I say for, and then I'm going to just come up with a name. I'm going to call it pix. Sure, for pix in range 0 to, let's go to 10. What that's going to do, it's going to run through a loop, and it's going to take it's going to run 10 times, 0. It's going to start at 0, and it's going to go all the way up to 9, and it's going to assign that number to pix. Let's see. I can see that if I said print, I made up the word pix, could be anything you want. If I say print pix and go to my serial monitor, it's going to run all the way to 9. It's going to repeat over and over, and I'm about to crash. Yeah, oops. I just made a mistake that I could have avoided by using a delay. So what I just did, I just crashed circuit. I just crashed mu, and the way I did that, I'm going to go ahead and close that program. The way I did that was asking mu to print to the screen in a while loop. And hopefully when it comes back, my serial monitor won't be on. When it's printing, this processor on here is very fast, and it's trying to print 1,000,000 times a second. So I said in my while loop, I said print. Yeah, let's do from time import sleep. And you never want to just ask the processor to just print to the serial monitor that often, because that's a time-intensive thing to print to the serial monitor. And if you try to do that 1,000,000 times a second, you're going to cause the thing to crash. So I'm going to say sleep just 0.05 seconds, just anything other than infinitely fast. So now if I open my serial monitor, I can see that it's counting. Maybe just so I can see it, slow it down. So I do it every half second. So there goes 0, 1, 2, 3. So it's counting. It's going to go up to 10. It's actually going to go up to 9, and it's going to start over again. When you do in Python, in the Python programming language, when you do a range, the first number is included, the last number is not included. So pix is going to run from 0 to 10. Why are we doing this? Because I can use that to change the colors of my LEDs. So I'm going to say CPX.pixels .fill, and let's do, I'm going to have a range go for I from 0 to 255. So 255 is fully on. Fill I, 0, 0. So what I'm going to do is I is going to start at 0, and it's going to run all the way up to 255, and that number I is going to be the red value, and that's going to, I'm going to run through 255 of those. So let's make that really fast and see what happens. That's going to run as fast as it possibly can. And let's see. Oh, and fill takes. You can read the error. It takes. It really just takes 1. We can explain later why it says 2. It really just takes 1. So I need to group all of those together. And so I don't know if you can see it, but right now the LEDs are starting at 0 and fading up to 255, and you can kind of see that cycle. So that's kind of a cool way to take advantage of these pixels. I've started at 0. There they go. They're fading all the way up. And with a I can just kind of copy that and come up with some cool ways to make my lights turn on. So I can do another for loop. So the red is going to fade up to 255. Now let's have the green fade up to 255 and see what happens. So now I'm going to, right after the red is up at 255, so red's going to get to 255. Now I'm going to have the green fade up and see what happens. So I'm going to just hit save. Red is going to fade on. Once the red is fully on, the green is going to fade on. And if you might remember from, that's 0. Let's have, yeah, so you can see that the green faded all the way up. Now the red's going to go up, then the green's going to go up. That's pretty cool. Or I can leave the red at 255. And as the green fades on, that's actually going to create yellow. If you remember from art class, additive colors, red and green actually makes yellow. So once red's fully on, the green starts fading in. I'm going to go through orange and get to yellow. Then the cycle will start over. And then let's do one more loop in there just because that looks kind of cool. Let's do one more and have red fade down. So I'm going to say 255 minus I, leave the green at 255 and have the blue fade up. So now I have 3 for loops. First red's going to fade on, and then green's going to fade on. Then as red fades out, blue's going to fade on. Let's hit save and watch it work. So I've got red. Once the red's fully on, green will come in, which will cause it to go through orange and then yellow. And then the red will fade out while the blue comes on. I should end up with a bluish green at the end right before it repeats. There's kind of a bluish green called cyan, and then it'll probably repeat. So you can see there's lots of extensions of that, but that's a fun way just to get started with the NeoPixels on here. Again, I can use fill and give it 3 numbers in a group to fill all of them, or I can address those pixels individually, and there's some really cool permutations there. All right, stay tuned for the next video where we're going to really start diving in to some of the sensors on the CPX.